Welcome to qnawire.
So we have a hot air balloon, and we have to realize that this hot air balloon must be stationary. So we have this weight of this load. We have the force of the heated gas within the hot air balloon. And then we have the force of the buoyancy force. Essentially, this hot air balloon is um, displacing a certain volume of the atmosphere around it, which means that the buoyancy force is going to be pointed upwards because, of course, one can say that this hot air balloon is completely immersed in air. So we can calculate the buoyancy force of the air. And we have to realize that the sigma F, the sum of forces in the y direction, must equal 0 because we're not trying to go up or down. We're simply trying to stay suspended within the air. So we can say that we can redefine these variables completely and say that the weight of the air minus the weight of the heated gas minus the weight of the total load must equal 0. The weight of the air can be defined as the density of the air times the volume being displaced times the acceleration due to gravity. And then similarly, the weight of the heated gas can be the density of the heated gas times the volume. These two variables are going to be the same because the heated gas has a volume that is equal to the amount of air that is being displaced in the atmosphere. And then times g, the acceleration due to gravity once again. And then we have a load. They're saying that the hot air balloon and the propane tank and the passengers on board, all of this is going to equal 5,800 newtons. At this point, we can solve for our density of the heated gas. So plugging in for our constants, we have the density of the air times the volume times gravity minus the density of the heated gas times the volume times gravity minus 5,800 newtons must equal 0 newtons. So here we need to solve for the the density of the heated gas. So the density of the heated gas will simply be equal to the density of the air times the volume being displaced times the gravity minus 5,800 newtons, all divided by the volume displaced times the gravity again. So plugging in for our constants, we have 1.23, and then the volume being displaced is 2,200. 9.8 is the acceleration due to gravity, minus 5,800, all over 2,200, 9.8. And coming up here, we find that the final answer is going to be 0.961 kilograms per cubic meter. So again, we need to realize that this is being suspended in air, which means that if this is being suspended in air, the sum of forces in the y direction must equal 0. We must draw a free body diagram to see what forces are present. They're giving us a load, and then we're using the definition of density in order to find the mass. The mass times the gravity will, of course, be the weight. And solving for the density of the heated gas, we find, again, that final answer is 0.961 kilograms per cubic meter. And that's the end of the solution. Thank you for watching.